Hi guys, Mr. Reese here at Park Hill High School, talking about Algebra 2, Section 1.6, Linear Inequalities. These are our inequality symbols. There's 4 of them. They're listed here. We all kind of know that like the Pac-Man eats the bigger number kind of thing, so 5 is greater than 2, and so these are these symbols here of representing which is bigger than or less than another number. We're going to do some line graphs here, and these are what they look like. You may be familiar with these from Algebra 1. Couple things to notice: closed dots, that's because you have the line underneath the symbol, whereas open dot, you don't have the line underneath the symbol. Less thans are to the left, greater thans are to the right. When you're talking about with 2 variables, which happens sometimes, 2 variables, you're going to have a coordinate plane, so like an x-y axis, whereas 1 variable, you just have the 1 number line. So there's a difference in how you graph something with 1 variable versus 2 variables. 2 variables goes on a plane. When you're solving and graphing inequalities here, they kind of work just like equations. So in this example here that we're given, we're going to subtract 5 from both sides, divide both sides by -3, and we get our result. Notice here that our sign is flipped. So it was greater than, it's flipped to less than. That kind of happens because of our little one detail we talk about. Whenever you multiply or divide by a negative, you have to flip that inequality sign. Typically, we'll ask you to graph it as well, and so we've shown that here with an open dot shading to the left of -4. Compound inequalities are inequalities that have multiple pieces to them. So here we have an AND inequality and an OR inequality. When we show the AND inequality, first of all, I'll graph the first bit, which is this: x is greater than or equal to -1. So from -1, closed dot and to the right. Then we go ahead and add in the second part, less than 5. What we notice here is we have 2 different lines, and showing 2 different lines is probably not something that we want to do. So and, what this word really means, and means that we are talking about where they both exist. And so if we collapse that down, we're just talking about these numbers between -1 and 5. And so that's how we usually show our answer. The OR problem is a little bit easier because we go through and you don't have to do anything. Less than 0, less than or equal to 0, you graph that. Greater than 4, you graph that, and the problem's over. One extra side note to kind of know is sometimes we also can write AND inequalities using this one complete sentence here. We can't do the similar thing with OR problems, just with AND problems. A couple of examples for you. Here's one. So if we're going to go through and solve this, we do it like a regular equation. One thing to notice, when you add 5 here, you have to add 5 to the left and to the middle and to the right. It's like a normal equation has 2 sides. These equations sort of have 3 sides of the equation. Same thing here. When we divide through by 2 on the left, on the middle, and on the right, and we get our final example. Notice this is an AND problem, so it's going to be shaded in between with 2 open dots. Similar for OR, you do each of them independently from each other. Subtracting 1 or subtracting 2, you divide or multiply to make this happen. Notice from here to here we had this trick happen again where the inequality changed. That's because we had to divide by a -2. We'll go ahead and show the graph here. My face is kind of on that 12 part of the graph, but we're talking about an OR, so they'll point away from each other, less than -2 and greater than 12. These are the things you know how to do. Thanks for watching. Appreciate it.